Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 1248, count number of nice subarrays. This is a medium difficulty Leetcode problem, and the problem description tells us that given an array of integers called nums and an integer k, a continuous subarray is called nice if there are k odd numbers on it, and we want to return the number of nice subarrays. So here's an example of two nice subarrays, this one here and this one here, and they're nice subarrays because k is 3 and they have 3 odd numbers each, 1, 1 and 1. So how can we solve this problem? Well, you might think let's use a sliding window, but the problem with using a sliding window is sliding windows work best for monotonic problems. So if shrinking makes the solution better, and increasing the window size makes it worse. Very simple logic there. But here we don't know when to actually shift. If we could shift, we could end up waiting here and keeping this 1, or we could end up deciding not to keep this one, and then we'll end up finding the second solution. So there's two solutions here, the first solution which goes up here, and the solution from the end. But regardless, whatever decision we make, we won't be able to get all of the subarrays. We'll only be able to get, at most one with the sliding window technique. Or, if we did get the first one, then we would somehow need the magical intuition to know that we need to remove this 1, but there's nothing that could tell us that. So using a sliding window would not actually work for this kind of problem, or at least a naive sliding window technique. I think there are ways to actually refine the sliding window technique, and there's you can derive from that better techniques to solve the problem using a sliding window. But a naive sliding window approach would not actually work for this problem. So what could we do to solve this problem? Well, if we can't use a sliding window for this kind of problem, we kind of can assume that we want to solve this problem using a prefix sum. So using a prefix sum and hash map. So we want to use a prefix sum and hash map to solve this problem. And basically, this problem is the same as Leetcode video 560. If you haven't watched that video, I definitely would recommend, but it basically is the gold standard for how to solve prefix sum and hash map problems. But the logic there is exactly the same logic here. So we can see that we have, odd numbers. Here it could be 5 and 1, or it could be 2. It could be 2 and 1, but somehow we have an even it could be 4, or it could be 6, or it could be any even number here. So what we want to do is we want to make it such that all the odd numbers will stay as 1 and all the even numbers will keep as 0. So we'll basically convert this entire list into 1s and 0s. So it'll be a lot easier of a binary, kind of like a binary data structure now. And then what we can do is we can say, well, all the subarrays that have the sum equal to k. So here we have 1, 1, and 1. If they are equal to k, where k is equal to 3 in this example, well, then it's basically all the subarrays which have a sum equal to k. There's no more fancy logic that we need to do. We just need to look for all subarrays which have a sum equal to k. So that makes it a lot easier for us, and we can use the logic we've used to solve other problems as well. It's basically Leetcode 560 once you've figured out that we need to convert all of these numbers into a binary 1 and 0 format, where all the even numbers are 0 and all the odd numbers are 1s. So I'm actually going to walk through an example. We'll use this example over here again. 1, 2, 1, 1, 2, 1, 1. Okay. And actually, I won't go through the entire code, the entire flow. I'll pick one of the subarrays that I want to choose. So let's say we've got a prefix sum, and we've got the count. And I don't know. Let's say, okay, let's go for this one here. So here we will have, it looks, actually, let me put the prefix sum underneath. So this is going to initially be 1. This is going to be 2. This is going to also be 2 because we're not going to add anything to it. It's going to be a 0. This is going to be 3, and this is going to be 4. So we want to find out if this one, let's say we've got to the end of our subarray and we found this subarray. So we want to know, is this subarray a nice subarray or not? Well, we can say 4 minus k, well, 4 minus k is going to be 4 minus 3 equals 1. Is 1 in our prefix sum and hash map? Well, 1 will be in our prefix sum and hash map because we would have gone to this position 1 and we would have basically added it as counter 1. So we can say, yes, there is a 1. We can remove a 1 to make this subarray a nice subarray. And so we'll find a nice subarray here. And then we can do the same, of course, for here. And we can go through the entire list. But this is just one of the subarrays that I've chosen to solve, to kind of illustrate the example. But I hope that kind of makes sense. It's going to be the same algorithm. It's going to be the prefix sum, which is going to be x minus k. It's going to give us a difference, and we want to look in our hash map, does that difference exist? And then use that difference. So let's actually get to coding this problem. The first thing we're going to do is set a count hash map. I'll call it, we'll have 0 and 1 here. And this is, this is for problems when we start off with, let's say we have 1, 1, and 1 initially, and this is equal to 0. So we have the sum is equal to 3. Well, 3 minus 3 is going to give us 0. There's going to be nothing with the difference of 0. So we want to have 1 there by default, just so that we can best this edge case, so we can beat this edge case basically. So then we're going to have a current sum, which is basically going to be our prefix sum. I'll just call it current sum, and then the result, which is going to be 0. And then we want to say for each number in nums, let's get whether this number is a 1 or 0. And how can we do that? Well, we can say current sum plus equals, and if we want to find a number is odd or even and kind of map it to 1 or 0, well, we can say n mod 2. If it's an odd number, it will just give us 1. If it's an even number, it will give us 0. And so that's great for mapping the numbers to a binary format. And then we can simply say result plus equals count dot get current sum or 0 is going to be what our result is incremented by. Actually, it's not going to be, it's going to be current sum minus k. So we want to find the current sum, and then we want to subtract it from k and find the difference. And then again, we can now set this. So we want to set a new prefix sum and count. So current sum equals, and we want to increment it by 1, and then return result. Amazing. Let's submit our code. And now I think I've done something wrong because, yeah, I probably have done something wrong here because it's taking forever. So let's look through the code. For each num and nums, unless my Wi-Fi is strangely very slow. Okay, no, it really is just wrong output. Okay, this is the problem. We've just copied the exact. It shouldn't be current sum minus k because we're not setting the difference. We're setting the sum itself. Okay, now hopefully, yeah. So now we passed all 38 test cases. So it was a problem on my end, guys. Apologies for that. So in terms of time complexity, big O of n for both time and space. Big O of n for time, obviously, because it's linear, and big O of n for space because we're storing all the values in our hash map, worst case scenario. So with that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.